Good morning, everybody. My name is Ross Bradson. I'm the Regional Director for Southwestern Ontario here at OCE, and I'm also the Sector Lead for Advanced Manufacturing. Unfortunately, Minister Goodyear couldn't make it this morning, so apologies for that. I would like to introduce our moderator today. Thank you, everyone, for joining this panel session on 3D manufacturing beyond the hype. It is my distinct honor to introduce our moderator for this session, Dan Misener, producer of Spark and national technology columnist at CBC Radio. Dan is a radio producer and technology columnist with CBC Radio. He produces the national technology and culture program Spark and is heard weekly on 21 local afternoon radio shows across Canada. Welcome to Discovery, Dan.
Thanks very much, Ross. Good morning, ladies and gentlemen. As Ross mentioned, my name is Dan Misener. I'm really pleased to welcome you all to this panel discussion, 3D manufacturing beyond the hype. And right now what I'd like to do is introduce you to our panelists. Our first panelist is Ryan Schmidt. Ryan is a research scientist and the head of design and fabrication at Autodesk Research. Ryan is the creator of several 3D design tools, including one you may have heard of called Meshmixer. This was acquired by Autodesk back in 2011, and at Autodesk, Ryan has evolved Meshmixer into one of the standard tools for 3D printing. He's invented novel techniques for design-to-print analysis, support structure generation, and geometry processing, and in his current work, he's exploring the new design workflows that are possible because of the combination of 3D scanning, mesh modeling, and advanced digital fabrication. Thanks very much for joining us today, Ryan. Our next panelist is John MacDonald. John is with Solid Concepts. They're a custom manufacturing company that specializes in advanced manufacturing technologies, including additive manufacturing, 3D printing. Solid Concepts focuses on industrial 3D printing applications, and they deal in the aerospace world, medical, business consumer, entertainment, a number of verticals. And John assesses current technology platforms to figure out where 3D printing might replace traditional manufacturing practices. And then what he does is provides a more robust, economical, and as he describes, case-perfect alternative through additive manufacturing solutions. John has a really interesting background. He joined Solid Concepts in 2008 after spending 27 years in tool, die, machining, and molding for the automotive industry. So he brings that experience in traditional manufacturing procedures, and it really gives him an expert appreciation for the ways that additive manufacturing might further transform the methods of prototype and production today. John's specialty is in advanced manufacturing applications for the medical device field and also for automotive operations. And some of the things that Solid Concepts has achieved over the past couple of years include really large-scale end-use parts for aerospace ducting, low-volume production of medical prototypes and learning tools, and metal 3D printing and really high-end plastic 3D printing. We're really excited to hear what you have to say. John, welcome. I'd also like to welcome Gary Biermann. Gary is Senior Staff Researcher for Technology Transition, Corporate Engineering and Technology for Lockheed Martin. Gary's focus is on technology transition to new markets and figuring out collaborative research agreements that serve both Lockheed Martin's core markets and adjacencies in areas such as advanced materials and nanostructures, advanced sensing and signature technologies, and advanced computing platforms. Gary has been good enough to come up from New Jersey to be with us today. Thanks very much for coming up, Gary. And finally on the panel we have Paul Banwatt. Paul is a lawyer who's licensed in both New York and Ontario, and currently he's the COO and General Counsel of Matterform Incorporated. They're a 3D scanner company based here in Toronto. And before joining Matterform, Paul was an associate at Gilbert's LLP, where his practice included issues facing disruptive industries, global health law, social financing, media and entertainment, and complex intellectual property litigation. Paul regularly lectures on this stuff. He talks a lot about 3D printing and scanning law, and he's also the founder and the main contributor of the 3D printing and scanning law blog, which is called Law in the Making. Thanks very much for being here, Paul. I'm really pleased to welcome this distinguished panel. We're going to have a question and answer period after we hear from some of the panelists. But really, I'll ask you to hold your questions till there are microphones set up. But I'll ask Ryan, maybe you can start things off by telling us a bit about some of the design considerations that go into 3D manufacturing and sort of what you're seeing at Autodesk right now.
Sure. Yeah, but I need the clicker. OK, so this session is about the hype of 3D printing and the non-hype that also exists. And so I thought I'd just start by talking about what the hype is. So on the screen here, you see MakerBot Replicator. This is a sort of consumer-level printer. These exist. I have one at home. You can buy them, a couple $1,000s. That's how much a computer used to cost. That's not hype. Those exist. But when people talk about these machines, you often kind of get the impression that you don't need to go to IKEA anymore. You can just buy one of these and print out your consumer products. But the reality is what they can produce is there on the right. You see little plastic toys and things like that. That's usually the examples that you see, like if you go out here and see some of the 3D printers around, that's what people have on the table. And you might get the impression that that's all they can do, that's all they're good for, and that so you don't really need one in your house. And I would agree with you. You don't need one in your house. Unless you're an engineer or designer or you have a small startup where you're making some kind of hardware, or you're some kind of tinkerer. I use mine in my home renovations. So if you like to make things, this is a great tool. And I think of it as a tool, like a hammer or a screwdriver. And I'll show you this example. This is a good project, I think, to illustrate what you can do with these kind of printers today. So this is the RoboHand project. So this is initially started by a guy who knew this kid who needed a prosthetic hand. Prosthetic hands are really expensive. They're complicated. And so he had a 3D printer. He knew how to design, CAD things. So he designed this hand, this prosthetic hand. It's not all 3D printed. It's a bunch of pieces. It has screws and wires and things like that. But he could make this hand. He can manufacture it at home. And so he started this project, RoboHand. Now there's hundreds of kids using these prosthetic hands. It's not a prototype. It's not science. It's a functional thing. You can actually email RoboHand if you need a prosthetic hand, and they will find someone locally to print a prosthetic hand for you to help you with the fitting and stuff like that. So I think it's kind of amazing. That's a real project. And they open source this project. So it's on this website called Thingiverse. And you can go to Thingiverse and you can download the design for the RoboHand. And you can modify it. And you can make your own design. So on the left here is a version of the RoboHand that doesn't have any of the screws and wires. It's all snapped together. So that means you don't need to find the bolts that fit precisely and stuff like that. It's not as robust, but it's easier to make. The one on the right is called the Cyborg Beast. This is the sort of current state of the art if you go and look at what these people are doing. You see it's a much more evolved design. It's got like protection around the wires and things like that. So this was all done by people over the internet. A lot of it was done by hobbyists. These aren't professional designers, all of them. They have a 3D printer. So what they can do then is they can manufacture these parts. And until we had consumer-level 3D printing, that wasn't realistic. You couldn't iterate on a design in your basement for a functional thing. So this isn't a consumer product. You don't press print and a thing pops out. This is complicated. But it's a thing you can do if you are interested in making things. You have this capability. And actually, I was walking on the show floor yesterday, and I saw a few of the different companies around here. If you look at what they're showing, some of the hardware companies, a few of them, you'll see little 3D printed parts in that design. And if you know anything about manufacturing, you know that it would be completely impractical for them to do the tooling to make the molds to make these little pieces. But they can do it with a 3D printer at home, or in the lab. And so prosthetics are a really interesting domain because most prosthetic work right now is done manually. So this is my collaborator, Matt Ratto, and this is a project we're working on where on the left there you see he's holding a little brown thing. That's a prosthetic leg from Uganda. So that's what the kids there who need prosthetic, below the knee prosthetics, that's what they get. And on the right he's got a 3D printed version. And so what we're working on is a project where we're using 3D scanning, some design tools, and then a 3D printer to try and deploy a system where they can design a better fitting prosthetic, a higher end prosthetic for these kids in Uganda. So we use this system is supposed to scale out to thousands of mobile prosthetic units, so we have to use cheap things. We can't use high-end 3D printers. So we use a Microsoft Kinect to do the 3D scanning. We use this software, Autodesk Mesh Mixer, which I work on, to design that prosthetic socket. There you see an example. and then we use a MakerBot to print it out. And so this is a real project. This isn't a prototype also. We're working with CBM Canada, which is an international NGO in a hospital in Uganda. And the goal here is that we can deploy this system in Uganda. The Ugandan technicians will design the socket. So they use Mesh Mixer. It takes about 10 minutes to design this socket. And that's another thing I think is really interesting here, is that once we have 3D printing like this, we can use different kinds of design tools. So that's one of the things we're doing with Mesh Mixer, is we're trying to make different kinds of design tools other than like SolidWorks or Inventor, things that you're probably familiar with, where you can't make the same things you can make in Inventor, but you can make things that are possible that would be really hard to make in Inventor, like something that fits a complicated shape. You can make that very easily. And so another interesting design side aspect here is that, if you saw the keynote yesterday, he mentioned that complexity is free. And I would argue with that a little bit. It's not entirely free, but it's almost free. And so this is some brackets from aircraft. So you see in the example on the left what the old bracket used to look like at the back. It's very sort of blocky shape, right? It's heavy. So what they did was this is called lightweighting sometimes. So they basically subtracted bits of it and changed its shape a little bit so that it's lighter. And so this is being used today. There's most recently one I'm aware of is there's a panel in an Airbus airplane that was just redesigned using this kind of approach to lightweight it. On airplanes, saving a kilogram saves hundreds of thousands of dollars in fuel over the lifetime of the plane, and that saves emissions, right? And so right now, that's practical in airplanes. It's not practical, say, in your normal car yet, but it's practical in very high-end cars. But as that sort of curve of cost goes down and ability to optimize the shape goes up and saves you more money, I think it's not going to be long before those points cross, and you'll start to see 3D printing like this used in a lot more design applications. So this is another example of a thing we're working on at Autodesk to sort of automate this, so you can give it a design, and it will figure out how to lightweight it. Because a lot of times this doesn't matter. It doesn't actually matter what the lightweighting looks like. It's not a design feature, visual design feature. It's a functional feature. And so this is a place where advanced algorithms can come in, the sort of artificial intelligence, machine learning stuff that you hear about. This is a place we can apply it very easily in design processes to make things cost less to manufacture and also be more functional. And so those are some of my examples of what you can do with this stuff today. So these are all examples that are plausible today. These aren't future, I would say they're not hypey things. They're not, sometime far in the future. This is stuff that's happening right now.
No hype. The straight dope.
Straight dope.
Thanks, Ryan. Really, really interesting examples. Let's move along to John MacDonald. John, at Solid Concepts, you're focused more on sort of industrial 3D manufacturing. Yeah, maybe you can tell us a little bit about the kinds of things that you're working on in the different verticals.
Yep. Okay, so I skipped the first slide, but additive manufacturing is also considered 3D printing. The difference between additive manufacturing and standard manufacturing is you're actually adding the material as opposed to taking it away. So where is it being used? It's being used in prototype, it's being used in pre-production, and it's being used in production. Now the big question that comes across, everyone says I want it 3D printed. 3D printed comes into a number of different technologies. As Ryan had mentioned about the MakerBot, that's considered an FDM technology. You also have SLA, you have the Z Corp, you have SLS, FDM, and then you do the metals with the DMLS. So really, when someone comes to me and says, I want it 3D printed, it's like, okay, what's your end-use product? What are you using it for? Now, we talked about the hype and basically where it's going to be used at. This little graph, I don't know if, hopefully you can see it, it shows where the different technologies really meet well with the development stage of a cycle. Because you need to see, okay, when you're first starting off, you want a basic, simple part. But as you get into production, you need to use maybe production materials or different things that way. The hype. This is where the hype is. If you can see the far right-hand side, that's in $100 million. The 3D industry in 2011, I believe that is, was a $2 billion industry, and it keeps growing. As they're making the MakerBots, which is going to be a cheaper product, people are going to be more and more involved. And it's really teaching the engineers to go more simple, or more complex, really, and get away from the standard manufacturing. Some of the areas where we've done it, anatomical models for training aids for doctors, dentists, whatever sort of thing. We do a lot of that, and all 3D printed. Medical applications, big industry for a lot of the 3D printing because it's smaller volume stuff. You know, when you get into the smaller volume, it makes it very devices, handheld devices, cases, surgical guides, really pretty well everything in the medical industry. Engineering evaluation, whether it be a wind tunnel or the little aircraft there, that really shows the stress analysis when the plane is in flight. That's printed in color on a 3D printer where, you know, you have a bunch of engineers, they all can look at the 3D file on the screen and they know what they're looking at. You take that to a boardroom or an executive room where they don't understand the 3D screen, you know, you can show it to them right there and they say, oh, now we understand where the stresses are. Now we understand why you want to do something different or why it's going to work. Transportation, under the hood, black and buried parts, as I like to call them, air intake manifolds. You know, the interior of that car is a show car that was all 3D printed. It's all FDM printed 3D. Aerospace, they mentioned earlier, the complexity of those shapes on the aerospace, the gray part on the left-hand side is actually a fuel tank. Unmanned vehicles. I mean, everyone's heard about the drones and everything that's going on. The parts being used right now are production. The gimbal on the top is actually a company out of Waterloo, Ontario, Ariane Labs. They've given us permission to show their part, but we make that in production for them. The little camera goes in there, and that's their little unmanned vehicle there, the picture of it. Art and entertainment. WALL-E. We printed WALL-E for Disney. You know, it was used around the theme parks. You know, as Ryan said earlier, you have your little toys and stuff like that. It's used all over the place. Architectural models. That model there, the gray one, is actually the city of San Francisco, where they've wanted to have a model. You know, if you're doing a project for a large building and you want to make a 3D printed model, it can be done. DMLS, which is your metals. You can see the American penny there in comparison to the size of the parts. You know, the DMLS is coming along, and I know that my colleague Gary here is going to be talking more about it, so I'm going to skip over because he's got a lot of good examples to talk about. Large panels. You know, these here robots, medical robots, the applications are used all over the place for large panels that it doesn't make sense to build an injection mold when you're only going to do 20 pieces a year. So how do you determine which 3D technology you want to use? You know, it's the application, it's the size of the part, it's the material, the accuracy you need, when you want it, and your budget. You know, some 3D printed parts, if you order it today, we'll deliver it tomorrow. Other ones, it takes 3 or 4 days or a couple weeks. Once you get into the aerospace, we can produce the parts in a week, but our quality requirements to meet FAA and Transport Canada will add an extra 2 weeks onto your delivery. This is a little graph, and I'm not going to go into detail on it, but it actually talks about the different plastics components and where they fit into the spectrum of precision versus cost versus speed. You know, we've put that together for that. I'm going to skip over questions because they're going to come to the end. But really, you know, if the 3D printing is coming a long way, and there's many other examples out there that we can't show due to customer confidentiality, but it's out there.
Thanks very much, John. We're going to move along to Gary Biermann. Gary, you're at Lockheed Martin. Maybe you can tell us a little bit about sort of the world right now at Lockheed Martin and where you see things headed in a couple of years.
All right. I'll be happy to do that. Oh, sorry, I got to back that up. All right, so I thought I'd start out with some real examples. Some of the parts you see on this graph are actually on their way to Jupiter right now. So that was launched in 2011. Lockheed's been working on additive manufacturing for some time. And those tend to be in the size that a lot of the folks have been talking, relatively smaller waveguides, brackets, et cetera, using titanium in this case. Most of what aerospace is interested in is in the metals area, and we're also very interested in new compounds that we're engineering using nanomaterials and others. But here's an example of electron beam melting where we got real cost savings, 2x cost savings and schedule savings, and that's a big deal in aerospace. Space qualified and flight certified equipment, it takes longer to certify it than it does to design it. So what we're hoping for in the future actually is to be able to certify the process in which you use to build it. So from molecular modeling out to the end part modeling, if you can certify that and remove a huge part of the schedule at the back end, certifying the parts, it's a big deal. Other examples of things that we're doing is E-beam direct manufacturing, and this is to show where we're going with scale. That's a 7-foot diameter hatch that's made completely on EBDM. So these are not just going to be little parts anymore. They're going to be big structures, and we're moving towards that pretty rapidly. Certification for that is this year. Another example, everybody's heard about F-35 fighter and the cost associated with that, and we're continually working over the life of the aircraft to remove costs. We've done a pilot project. We've decided a couple of parts that we think will have a significant cost reduction and schedule reduction by going to this kind of technology, and we'll be piloting that shortly, and eventually that'll be put into the aircraft, and we will continue to do those sorts of things over the life of our products, many products. This is just an example. Where do we see this going? It's really an interesting convergence. It's not just the equipment and the design tools that you need to make this. I mean, they're coming along and it's real. It's really the materials that we're talking about. We can engineer materials today that don't exist in nature. And when we start combining that material engineering with the tool engineering, with the machines to make this stuff, you start to get into some really interesting capabilities. And here's some crazy examples of things you might do with it, kind of high-end, hard-to-do things, nuclear, high-temperature things, et cetera. But there are real needs out there. And where do we really think things are going? A lot of folks have shown you poly parts, plastic kind of parts, and we use them too, but primarily for rapid prototyping. There are some cases in UAVs and others where we might actually build parts out of this, but a lot of what we do with this kind of technology is really to get our engineers a quick look at what's going on and whether or not it's going to work out for them, and then also to do some design trade-offs. And in a quick and easy way. I mean, these parts are a couple hours. That's what's great about it. And the other panelists have made that point. That's a huge big deal to see it, to feel it, to know that it's real. Large additive deposition. There's a lot of work going on in the U.S. and certainly beginning to go on in Canada. And Lockheed is very interested in what's happening in Canada. But we're working with Oak Ridge National Lab now. We actually gave them their first equipment to get started. And how do you make really large structures in additive manufacturing? How do you get past the little pieces into sections of wings and fuselages and other big structures that will really make a difference in the cost of our products going forward? And where do we really see it in the future? It sounds kind of Star Trek-ish, but we think it's only about a decade away. When you talk about the tools that are coming online, being able to really model at the molecular level what is going to happen with the material, all the way out to how are you going to lay down different materials simultaneously with multiple robots, with multiple material heads. We envision a time when Lockheed may have one big factory somewhere. And planes will roll out, and satellites will roll out, and all kinds of good stuff will roll out the end of it with unique design tools really being the leverage that makes that happen. So that's it for my end.
Just a quick follow-up, Gary. What's going to happen in 10 years? I mean, why is that the timeline?
I think a lot of it has to do with the material science and the tools being available. We're putting a lot of effort into working with folks like Autodesk on how do you really design the tools. And the trick really for us is the molecular level modeling. The CAD tools and the capability to build things and control robots and process flow is more understood. It's starting with the material science and then working all the way to that end.
Gotcha.
That's where we think it'll be ready by then.
We'll see. Paul Banwatt, clearly a lot of intellectual property issues here. This is your bailiwick. Tell us a little bit about what people in the room should have on their minds as they're thinking about the possibilities here.
Well, I'm going to do my best not to be the buzzkill lawyer at the end of an otherwise invigorating presentation about the future. So I work for a company called Matterform, and we make a low-cost 3D scanner. And it really is the 2D scanner to 2D printer comparison is perfectly apt in this case. We have a small object scanner. You can put something on it, it zaps it with lasers, turns it around, and creates a 3D model that you can then print out on a 3D printer. You can put it in a video game. You can do all kinds of things with it. So what you're doing is you're copying at that point. And anytime you're copying, you may be running afoul of, say, copyright. And so this slide, I think, is a nice little example. So this is from the site Thingiverse, which is a 3D model repository, and it's associated with the MakerBot scanners. MakerBot owns it. And on Thingiverse, you can upload any 3D model you've created you want, and people can download it for free. And here is an example of an Imperial Star Destroyer. And I don't know if you can read the text, but so on every page on Thingiverse, you have a license statement. So the person who uploads the model to Thingiverse says what license they're putting their model up under. Maybe it's Creative Commons. In this case, it says Imperial Star Destroyer by, and then the username is licensed under the public domain, which you don't have to be a lawyer to probably guess that's not okay necessarily from a copyright perspective, because Lucasfilm would probably not agree that the Imperial Star Destroyer or Disney or whatever empire currently owns the Star Destroyer would not necessarily agree that the Star Destroyer can just be freely copied under the public domain. And this is a copyright issue, and I'm going to talk a little bit more about other areas of intellectual property in a minute. But the truth is that these issues are tricky for people. And this we were talking about hype. This really isn't hype. The legal issues have started to come to the surface. There's the Tintin. I don't know if anyone's a fan of Tintin, but Hergé is the original author of Tintin, and the lawyers representing Hergé's estate have been issuing notices under the Digital Millennium Copyright Act. It's the Copyright Act in the United States that was brought in the 90s to respond to electronic technology, copying internet, MP3s, all of that good stuff. And what they do is they issue a notice through a service provider, in this case Thingiverse, to a person who's uploaded a model. And then Thingiverse, in order to avoid being sued by the copyright holder, takes that down and passes the notice along to the possible infringer. So people who have been putting rocket ships that resemble the rocket ship in Tintin, I've never seen or read Tintin whatsoever, so maybe some of you know what I'm talking about. They've been getting these notices and having their models taken down. One guy got a notice just because he took a picture of a model that he printed out and put it up online. And those people really are exposed to liability for what they're doing. In this case, I don't think that Lucasfilm has gone after these people yet. So it just brings me to my point about 3D intellectual property. It's very complicated. And I think people don't actually know, as they're entering this world of making 3D stuff, particularly in this low-end world. And we'll talk about the high-end world that these guys have been talking about in just a second. But in this low-end world, what you can and can't copy, it's actually really complicated. Just to give you an example, in the United States, there's been a recent case. It's not a strict 3D printing case, but it has a lot of implications. There's a guy who's making copies of replica Batmobiles, and he's showing them at shows and selling them in some cases. And a court actually struggled with whether the Batmobile is a character or a car for the purposes of copyright. Because if it's a car, then it's a useful object, and useful objects are not very well protected, especially particularly their useful features, by copyright, by trademark, and even by so-called industrial design or design patents. They don't necessarily apply to the useful features of an object. They apply to aesthetic features, ornamental features, copyrightable or protectable features. So if the Batmobile is a car, then maybe it's not copyrightable. And a US court actually said that the Batmobile is swift and cunning like a character. Sometimes it drives around on its own, and therefore it is the subject of copyright. Does that apply to the Tintin rocket? Does that apply to the Star Destroyer? These are questions that you can't expect an average person to know the answer to, or even a court necessarily. We're looking at this slide, what's not protected. This is one of my favorite stores in Toronto, mostly because I can afford to shop there. They sell furniture that looks almost exactly like designer furniture. And it's literally called modern furniture knockoff. And immediately you think, well, there's got to be something wrong with that. But remember what I just said. It's sometimes really hard to protect the useful elements of something. So if a bench is being sold by a modern furniture knockoff like the one I bought a couple weeks ago, and all the aspects of the bench are for sitting or holding up the bench, then those aspects might not be protectable. There might be some ornamental side of it that is, maybe there is, maybe there isn't. It's a big question, and you can't always get to the bottom of it very easily. I just want to move off that and talk about something a little more exciting from the new world of 3D printing. So one of the things I think is really interesting is how 3D printing and scanning technologies are changing the way we actually protect intellectual property. And so what you see here are a couple of figures from a recently filed patent application in the United States. And this is a 3D food printer. So sometimes when you're patenting something, the novel subject matter that you're patenting, the stuff that you're going to protect, isn't necessarily like the product or like the cup or whatever it is. It's the way you make it. It's the method of manufacturing. And in this case, this patent application is attempting to protect a method of manufacturing food. So on the left side, you see this sort of nozzle extruder dropping out these little balls of food one at a time and layering them in an additive manner. And that's basically what the claim reads like. And then on the right side, you see the delicious food polygons that are created by the food printer. And this is the kind of thing you'll see. So maybe you would make that polygon another way and you'd be okay, but if this patent is eventually granted, you know, if you make it through an additive manufacturing process, you may run afoul of a patent like this. You know, and you see a lot of different ones like that. I recently saw an application for like an Invisalign style braces set that was, and the entire subject matter of the patents revolved around the fact that it was being additively manufactured. It's 3D printed. That's why they're applying for a patent. And I just want to talk about something because it came up a lot before. You know, so I thought the stuff that Ryan was talking about, and actually I think it came up again after that, about prosthetics, is really interesting because another area, just another broad area that I want to bring up in 3D printing and scanning world, and a challenge that I think is faced by everybody really, is what happens with regulated and controlled goods when you change the way you manufacture something or you make something or you create it. And this is just one example because so some kinds of controlled goods are controlled at a level of, say, possession. You know, you can think of narcotics and you know, some of them you just can't have. Others are controlled through supply chain regulation. So, you know, you can't manufacture it unless you meet certain standards, or you can't sell it, or you, and medical devices are very much the latter in a lot of cases. There's strict regulation of the factories in which you create the devices. There's codes you have to meet. There's standards you have to meet. But if you change the way you make it, sometimes you change the way you miss the way the thing is regulated. So, you know, just to make this perfectly clear, a medical device can be something as simple as a tongue depressor. You know, and it's because of the way it's interacting with humans that it falls into this regime of medical devices. And so if you change a tongue depressor, if you manufacture a tongue depressor and sell it through the regular supply chain, you go through the regular medical device process, and it's a very low-level medical device, so you're exempt from lots of things. If you just 3D print one at home, though, then you've kind of avoided that whole system. And you know, I do think it becomes an issue because recently the FDA started regulating mobile apps as medical devices. And the reason is these apps were actually interacting with people the way that a medical device traditionally does, you know, medical apps. So they've started to crack down on it and issued guidance to the industry. And I think that 3D printing and scanning might be next. So those are just some high-level comments. Dan,
yeah, thanks very much, Paul. We've clearly got a lot of expertise on the panel here, and I'm sure you guys have a lot of questions for them. So we've set aside some time to ask those questions. We have 2 microphones set up, number 2 and number 1 right here. So if you've got questions, I'd ask you to approach the microphones. But maybe we can start the conversation and talk a little bit about why we're here right now. I mean, additive manufacturing, 3D printing has been around. The technology has been around for decades now, yet we are in 2014 sitting on a panel talking about hype around 3D manufacturing and additive technologies, additive manufacturing. Why now? Why is there such a focus on this right now? Why is this sort of in our, why is there sort of this sort of public understanding or a greater public understanding around these technologies and these issues. Why are we so excited about this in 2014 when it's been around for a while?
I'll take a quick crack. So if you saw the briefing yesterday and they showed the Moore's Law curve, we're not at the beginning anymore. We're moving along that curve, so it's starting to get more and more accessible. So that's really why the hype. If you saw some of our charts, we've been doing it since the 90s. But it was just an experiment at the time. It was just an interesting thing. We're actually making parts now, and it's real. And the price curves are coming down, so the accessibility is much higher today. That's why.
And in addition to that, I think the other thing is that the materials and the processes have come a long way. Like they said, 20 years ago or 30 years ago, you had a 3D printed part, you dropped it 2 inches, you had 1,000 pieces. Now they're using them in production. I mean, like the metals and the plastics, aerospace is using it all over for air ducts in their aircraft. So I think the hype is that the public is starting to hear more about this. So they're starting to see it. And as the one slide that I showed you, it's a $1 billion a year industry now. Wall Street is jumping all over 3D printed companies to invest in them and to invest in the technologies. Even the governments within Canada are putting money into investing in that technology. There's stuff going on with the Quebec government right now where they have taken some large manufacturers in Quebec and said, we want you to invest into and they're paying them to do the research to invest into 3D technologies to bring it into Quebec to have it manufactured there. So there's governments are looking at it, Wall Street's looking at it. People are seeing it on the internet every day. There was a thing that came out last week on China 3D printed houses. Basically it was a cement square box, but they still said 3D printed sort of thing. I think we got a question up.
I feel like I should mention as the lawyer that part of the reason that the why now is the expiration of patents as well. So in the 80s, there were patents filed on fused deposition modeling, FDM. It was brought up on a previous slide, I think John's slide. And FDM, by the way, is a Stratasys Corporation trademark. Be careful how you use it. But it was that technology was patented, and those patents all expired around the year 2009. So if you looked at the 3D printing landscape at the low end, particularly because FDM is a great technology to use in a low-end 3D printer, there was 0 low-cost 3D printers in, say, the year 2006. And after 2009, there's hundreds. So I think that's part of the reason you start hearing about it a lot more.
Yeah, and Paul, are there...
And to mention on that, also the SLA technology, which is your stereolithography, the patents are expiring on that right now, actually. So up until this time, there was one company that controlled all the material and all the process for the SLAs. While their patents have expired, now other people can bring it on more.
I think too, you mentioned printing food, and they're actually working on printing organs and bone and things like that today. So it's getting really interesting out there what they're thinking about 3D printing.
Let's take one of the questions at mic number 1.
So as the consumer space, as it becomes more accessible to the consumer space, one of the things that we've been seeing is the primary thing people are printing is trinkets and ornaments due to the limitations of plastic-based printing. You can only do so much with it. And I'm wondering if you guys can speak to ways in which the consumer space can be opened up to create more useful things. And I'm thinking along the lines of inclusion of metal pieces, maybe from a parts supplier. We're working on a startup that's looking at trying to bring some of these components like microcontrollers as part of kits into the 3D printing sort of ecosystem. So that's sort of the source of the question. So
from the consumer perspective, absolutely, consumers are looking at trinkets and gadgets. Solid Concepts, we are a producer, a supplier of parts. We don't manufacture equipment, we produce parts for startups and whoever sort of thing. So the materials are there, it hasn't hit the consumer level. There's talks about Staples in the US having 3D printed machines in their stores. You bring your file and you plug it in and you get a 3D printed part. But the technology of the more advanced ends, like you take the metal machines, those machines are $500,000, $600,000. You're not going to put that in your garage. You're going to go to a company that manufactures as a business and produces parts for you. And that's where it comes through to is the consumer. Will it come to the consumer level in years? Absolutely. You take a look at your phone right now has more power on it than a $2 million CAD system did 25 years ago. So it's going to evolve, but it's going to take time. Right now, there's a lot of service bureaus, such as who I work for, Solid Concepts, that you can buy parts from, and that's really what we do.
I think, I mean, what you're saying is true, that consumers right now, mostly, if they think I want to 3D print something, they're kind of limited to trinkets and things they can find already on the internet because it's really hard to design 3D things. So like, I do a lot of 3D printing at home, I mentioned before. I have a huge list of things I want to 3D print and have a very small set of things I've had time to actually design because the design tools are not made to be easy to design simple things in. And so I think that's really, in some sense, what's holding a lot of things back on the consumer side. So we do these workshops. I've done a few, and there's a few other organizations in Toronto that do them. For complete novices, they come in, and we teach them how to use Meshmixer usually, and then they do some little 3D printing project. They're really excited because they got to make a thing that they designed. It wasn't like they didn't download it off Thingiverse and print it. And so you usually see them to start thinking about like, oh, how could I use this? And one thing I always see is that if you have any kind of hobby, you won't think of it at first. It won't be immediately obvious how you would use 3D printing in that hobby. But if you have one available, and it's basically free to use, because the plastics for 3D printing on the consumer printers are essentially, the cost is so tiny, right? You start to see how you can use it once you start using it. It's a weird chicken and egg thing where you won't be thinking like, oh, I could design a bracket that goes on my stroller that holds my umbrella or things like that. My wife now is asking me all the time to design things for her so that she can attach to things. And so I think that's a big thing that doesn't exist right now. There's not the software that makes it easy for people to do specific. I don't think you can make a general system where you can just design anything in that tool. That's why the real CAD systems are very complicated. But if you look at specific domains and you can say, like, in this domain, what we need are these sets of tools, I think that's a really interesting space going forward. And we see a lot of small startups that are doing that in different areas where they're making a specific design tool for a specific problem. And I think that's really going to expand what consumers will think of doing with 3D printing.
Ryan, you said earlier that you don't think that most people could or should have one of these consumer-grade machines in their home. Right. Do you see that changing? Do you think the technology is going to get to a point where I might want to have one on my desk?
I think it might if it gets cheap enough that it's, like buying a toaster, where it's essentially kind of like a disposable machine. If it's the point, like right now, we mostly use the MakerBots. They're one of the sort of highest quality ones. They still cost several $1,000s. That price point can go down quite a bit. But even if it's a couple $100s, it's not going to be a thing that people just buy on a whim. But I think I see it more as like a thing, the same way that like I might have a drill and my neighbor has a power saw, right? Like if I need a specific thing 3D printed, you can find someone locally. So there's a thing actually called 3D Hubs now that you can go to and you can find local people with a 3D printer who are willing to print stuff for you for, the cost for plastic printing is crazy cheap. And then there's the mail order like with Shapeways. For metal printing, you can use Shapeways. We just ordered some metal things from Shapeways. It takes about a week. It comes. My wife told me that a bunch of her friends got 3D printed jewelry this year at Valentine's Day, which I assume was all from Shapeways.
Yeah, it's about the access to it. I mean, we're also starting to see these devices showing up in places like public libraries, right?
Exactly. Yeah. The reference library here has quite a big setup for 3D printing. Yeah.
We've got another question at the second microphone.
Hi. First of all, a quick comment on that Meshmixer. It's a very nice tool. Okay.
Thanks.
And very timely. It was very much needed. My question is actually for the gentleman from Lockheed. When you say 10 years, what do you, and it's okay to be rough. When you say 10 years, do you think that in 10 years we'd be at the point where we can actually look at trying to pass some regulatory laws to say, if you're going to try to use additive manufacturing, you gotta follow the following standards, and then you are in a position to perhaps look at manufacturing something that may endanger human lives? Or are we right now at that point, and in 10 years we have passed all those regulations? Because 10 years, it seems to me like a very short time frame, and I wouldn't want to get into an airplane that 10 years from now was built with machines, no matter how advanced they would be, because just from what I've seen, the aviation industry is very, very complicated. You probably have orders right now for the next 10 years already. So an airplane that 10 years from now will be ready to fly, you're probably looking at building it right now. But from what you've said, the material science is not there. The materials are not, we don't have enough knowledge of that. Is that correct, or?
We do have material science today that we can build things in titanium and aluminum alloys, and they're certified. So I want to be clear, there are parts that are flying today on spacecraft and will be flying in aircraft that meet the certification requirements. What I was talking about was really getting to building large structures, okay, on multi-materials. So what we're really talking about there is how do you take half a dozen different materials and build one structure out of a half a dozen materials with a robot all at the same time. And to do that and get it certified, what you need to do is certify the process from the molecular level on up. Not the part necessarily, but the process. And that's really where the groundbreaking schedule impacts and cost impacts are going to come from. Today, when we design a part, it may take 2 years to design a part and 3 years to certify it. What we're hoping for is if you certify the design process, that you don't have to go through 3 years of certification on the part. If that answers your question.
Who usually pushes this process? Is it the customers who order the airplanes? Is it you guys, the regulation? Who actually leads this?
In aerospace, historically, defense leads the way in taking new technologies forward because they have critical missions to meet. So it won't be on civilian aircraft first, it'll be on defense articles first, or spacecraft first. It's just always been that way. If you think about all of the innovations that we all carry around today that came out of aerospace, I mean, we all look at handheld devices. I helped invent that screen, and it was for aerospace. So it'll be defense that leads, and civilian applications after.
Just to close this, would maybe Boeing be in a position in 10 years to have airplanes that fly? Again, it's okay to be rough.
No, I think certain critical parts, some critical parts where it makes sense to use additive manufacturing, not the entire aircraft initially, but certain critical parts would definitely be there. You know, we're making large structures now, and we're going through all of the testing that you need to do on the part level, because that's what we can do today. We're not allowed to do process yet, to show that these parts are every bit as good as parts that are machined.
Just maybe Gary can answer this, and I'm pretty sure I'm accurate on this. The regulations for commercial aircraft are higher than the regulations for your military aircraft. So when Gary's talking about adding stuff to military aircraft, that's the first step. You know, there's the FAA, Transport Canada, European Space Agency, they all have very strict regulations. No matter what we do in additive manufacturing, we have to pass those regulations. I mean, we're doing parts right now for commercial as well as private aircraft, not using the metals, but using the plastics that are on production aircraft right now.
So it is close.
Thanks for the question. We'll go to Fanny at number 1.
Hi, everybody. My name is Fanny C., and I work at Mars Innovation. I'm involved in the commercialization and development of a bioprinter that was conceived in Toronto. So what I'm going to do is I'm going to give you a little bit of a pot stir. I'm going to say a couple statistics about a company called Organovo, who is the commercial leader in tissue regeneration using 3D printing. So the stock price of this particular company has fluctuated over 50% since its inception, since 2007. It has lost over $85 million. It has never launched a product. It is valuated at $650 million. Is that hype? Good question, right?
I think that's the reason the value and everything like that is that everybody wants that to happen, and everybody knows it's going to happen. So it's a matter of people are going to still invest money into that to bring it to today's, where we are today. You know, you're absolutely right. You know, what I invested in a company that's lost $85 million and has done absolutely nothing, it's, you know, if you look at it on paper, you wouldn't. But if you look at the hype and where people want it to go and they know that somebody's going to make it happen, then that's so I don't think it's hype, I think it's reality, it's going to happen.
Yeah, and I think, again, in the speeches yesterday, some of the keynote speakers talked about, you know, thank God for those early investors, right? Because they maybe have more money than the rest of us, but they're interested in socially important things. That's a socially important thing that maybe is worth investing in.
So just to follow up on that, what do you think is going to protect the public from things that work and things that don't? Because the market is infused with information every day, and we can't figure out what is good and what is bad. Like the FDA right now is having huge problems determining whether or not the outputs of the configurations of a printer are medical device, or if they're drug, or if they're combination, right? So,
I mean, it's a complicated question, you know, and in terms of investing, I think you get into that world knowing what you're getting into. So, you know, there's investor protections out there and an entire regime that may actually change soon, but to allow for crowdfunding in some ways. But yeah, there is protections there for people who want to get into that kind of thing. In terms of the devices and protection, you know, there is efforts underway to create standards. I know CEA we're involved with CEA in creating standards for 3D printing and trying to get in standards for 3D scanning as well. Industry Canada is also taking that up. So at some point, hopefully soon, there will be some standards that can tell you, well, this was done on a 3D printer that met this particular standard. This was done on a 3D scanner that could scan to this level of accuracy, and that'll mean the same thing to everyone. I think that'll give people a lot more comfort about things that are made with some of these devices. But when you start talking about like bioprinting, and you know, it's a lot harder then, because you're not talking about plastics and metals and things you can quantify. It's very innovative. One last thing I'll say though is that, you know, as much as 3D printing creates some risks like this, it also creates some benefits to, you know, for investors. So, for example, a lot of companies are using 3D printers for rapid prototyping. That lets them keep things in-house and keep their secrets secret. And then, you know, that creates a lot of value in terms of intellectual property there.
Yeah. We're coming up to 10 o'clock. I know we've got a couple extra minutes, but we probably only have time for one more question. So we'll go to number 2.
My question is for Paul, and it's a little bit of a follow-along for the previous questioner. In your part of the discussion, Paul, you focused more on the IP issues related to this space. But I'm wondering, like the previous questioner said, in industries where it's either highly regulated or when you get into tissue printing or organ printing, could you comment on maybe some of the additional liability law factors that come into play? How do you see that developing? Well,
yes, so I can to some degree. I think it's a really interesting area. Product liability is something I didn't talk about, but it is, so last year, you can look up, there's an amazing article in the University of Pennsylvania Law Review on 3D printing technologies and product liability, and it's a similar issue to what I was talking about, which is that when you change the site of manufacturing, you end up affecting certain laws that are based on where things are made and how they're made, and product liability is no different. So if you are, you know, making something and selling it through a normal commercial supply chain, then, you know, there's, in most jurisdictions you have what's called strict liability, and it means that the person, the end user of a product, is able to, without having a high burden of proof, just by proving that the thing was done, that the thing hurt them, have a claim against, you know, the manufacturer, the store they bought it from, all of the people in the supply chain. 3D printing can in some ways disrupt that chain of supply to the end user and can affect product liability in that way. When you get into bioprinting and whether things are regulated, suddenly the FDA has its own issues, and you know, I mean, it's too complicated to even start to talk about right now. But you know, at a very basic level, I think that these devices that give you a new way to make things, I think they do create those kinds of challenges.
Thanks very much for the great questions. Yeah, I'm going to turn it over to Ross Bradson again.
Yes, I'd just like to ask you to please join me in thanking our panelists and Dan Misener for moderating. Please enjoy Discovery. The next session in this theater at 10:30 is on cybersecurity. Thank you very much.